In my previous video, I shared my workflow of speeding up my samples before loading them on the K.O. so I could pitch them down to get some nice grit. I got a bunch of questions in the comments asking about this process, so I wanted to make a follow-up video to walk you guys through it. One important thing to note, all of the methods in this video can be used with pretty much any sampler. This stuff is not unique to the K.O. I'm focusing on the K.O. because it's a new toy and I really like the way it sounds, but every sampler handles pitching in a different way, so if you're using a different device, your sonic results may vary. Just a forewarning, this is going to be a very talk-heavy video, but I'll do my best to keep it concise while also making it as informative as possible. It's important to understand the why of what we're doing so the process makes more sense, and you'll also be able to use this information for general sampler use going forward. I'll be breaking this into 3 sections: the theory, the process, and the results. One of the crucial factors that has a major impact on a sampler's sound and character is its bit rate, which is a measure of 2 things: the bit depth and sampling frequency. You've probably seen people refer to the SP1200 as 1226, or the MPC60 as 1240. The K.O. is a 1646. These numbers represent the bit rates of the devices, with the first number being the bit depth and the second number being the sampling frequency. But what does this actually mean? Let's look at a quick example to understand. So here we've got an audio waveform. There are 2 attributes that will determine the quality of this sample: the resolution of the vertical axis, which represents the amplitude, which is the bit depth, and then the resolution of the horizontal axis, or the samples per second, which is the sampling frequency. Higher bit depth will result in greater headroom and lower noise floor, affecting the overall quality of the recording. Higher sampling frequencies will result in more high-end detail and clarity. Probably the most common audio quality is 16:44:1, or CD quality. This has kind of been the digital standard for audio for the last 30 or so years. 16:44:1 gives us 98 decibels of range and a high enough sample rate that it covers any frequency that humans are capable of perceiving, about 22 kilohertz. The highest audible frequency of a file is half of your sampling frequency. So what's the point of all this nerdy information? Well, it's important to understand what these numbers mean so we can understand the specs of the classic samplers and then what we need to do with our samples to emulate their sound. Let's now look at the audio quality of one of the classics of all classics, the SP1200. The SP1200 is 1226, which, as we've learned, means it has a bit depth of 12 and a sampling frequency of 26,000. A bit depth of 12 yields 74 decibels of range, and the 26K sampling frequency means it has a maximum audible frequency of around 13 kilohertz. When we compare this to the CD quality example, we can see we have a much lower signal-to-noise ratio, 74 versus 98, so that noise floor is starting to creep up and we're getting way less resolution to the audio. And then we can see that the SP1200's maximum audible frequency is significantly lower than CD quality, and that difference will be perceivable by the human ear. We're starting to lose the higher frequencies, and the overall tone is going to be darker. Now let's look at one more example, one of the lo-fi kings, the Casio SK1. The SK1 is an 8-938 sampler, so now we're talking a huge reduction in audio quality. With only 49 decibels of range and a maximum audible frequency of about 4.7 kilohertz, the SK1 is a wonderfully dirty little machine. So now that we understand these numbers and what they all mean, let's look at how we can manipulate our audio files to match some classic devices. So here we are in the DAW, and our goal here is to prep our samples in a way that's going to give us that classic lo-fi grit when we load them onto the K.O. Now, my DAW of choice is actually Studio One, But I decided to do this in Ableton Live since that's what the majority of you will be using, but this process will be very similar for any DAW. The first thing we want to do is make sure we're working with the highest sample rate possible so the pitching algorithm has plenty to work with when we start speeding things up. In Live, you will go to Settings, then the Audio tab, and then change the sample rate option to the highest available. Live's highest option is 96K, but if your DAW goes higher, I would recommend the highest setting to get the best results. Now we can close the settings. Now we need to make sure we're in session view, and we're now going to bring our samples into Live. So navigate to where you keep your samples and identify the ones you want to prep. Before dragging them in, make sure you set your live session's BPM to match the samples so everything lines up. This group of samples all have a BPM of 80, so we'll update Live to match. Now drag in your samples. You should press the Command or Windows Control key before releasing the mouse button so that each clip goes into its own track. Also note that because this process is tempo dependent, you can only batch process files of the same BPM. You'll basically need to repeat this process for all of the different BPMs in your sample library. Now it's time to lower our bitrate. Live has an included bit reduction plugin called Redux that's pretty good, and your DAW likely will too, but if not, there are free bit reduction plugins available online as well. Apply the bit reduction effect to the master bus. This is simpler and quicker than putting the bit reduction plugin on every channel, and because of the export options that we'll set up later, we'll get the same result. Now you just need to set the bit depth that you want for your files. This is strictly a matter of taste, but if you're not sure, you may want to just go with 12 bits. This is the bit depth of most of the classic samplers we're trying to emulate, so you can't really go wrong with that option. You can set it wherever you want, but anything lower than 8 bits starts to sound very broken. Next, we'll need to make sure all of our clips are set up to repitch rather than time stretch. This is the critical option that makes the pitch of our samples change as we adjust the tempo, just like it would on a turntable or tape machine. Open the clip edit view by double-clicking on one of your clips, then select all of your clips with Command or Control A. Click the warp mode drop-down and select repitch. Now we need to change our tempo to speed up our audio. Because the K.O.2's max pitch reduction is exactly 1 octave, we will always be able to easily dial in the original pitch if we export our samples in double time. This will also half the amount of storage space required for your samples on the K.O.2. Our samples are all 80 BPM, so we're going to double that and change the session tempo to 160. Now if you play back one of your loops, you hear that it's twice as fast and an octave higher. This may sound a little silly now, but this is exactly what we want. Okay, so with our bit reduction on and our sample sped up, we're ready to export. First, we'll need to set our loop point to align with our samples to define the export range. Now, go to File, and then Export Audio Video. Change your rendered track to all individual tracks, and then make sure that the Include Return and Master Effects option is turned on. This is what's going to send all of your tracks through the bit reduction plugin that's on the master bus while exporting. Choose a file type of WAV, and then I like to turn dithering off for this process, but that's optional and really just personal preference. Now click Export. Choose where you want your files to go, and then whatever you put as the file name will be the prefix for all of the exported files. Now click Save, and Live will render out the new samples. You can now navigate to the file location and preview them to make sure everything sounds right. Live adds a bunch of junk to the file names, so you'll probably want to clean these up before you load them to the K.O. But other than that, at this point, you're ready to load these samples onto the device. But because I want to see just how lo-fi we can get with the K.O. I'm going to do another batch of exports at 4 times speed, which should yield some pretty gnarly results. So this time I'm going to set the BPM to 320, again doubling it from 160, and then repeat the export process. Okay, so now we're at the K.O. and I've got the samples loaded. I'm not going to show the loading process because while it's pretty simple, it is slow. But the tool is on the Teenage Engineering website and is self-explanatory. So we can do some comparisons. I've got the same sample loaded 3 times. At normal speed in sample slot 1, at double speed in sample slot 2, and in quadruple speed in sample slot 3. And I'm going to put each of these on a different pad so we can compare. Let's start with the normal sample so we can have a baseline. I'll assign it to A1 and put it in one-shot mode. That's a pretty good sound, but let's load the double time sample to hear the difference. I'm going to load the double time sample in slot B1. Again, I set it to one-shot mode. But we can hear the sample is still super fast and high-pitched. To fix this, we go back into the sound menu and turn the pitch all the way down using the black knob, which is exactly 1 octave. The original again. And the double time sample slowed down. So what's happening here? There are 2 main factors contributing to this sound. The first is the pitching down we did on the sample. By doubling the duration of the sample, we've effectively halved the sample rate. Samples are converted to 1646 when they're loaded onto the K.O. Remember that the sample frequency is the amount of samples in the time domain. So by taking this 46K sample and stretching it over twice as much time, we've ended up with an effective sample rate of 23K, which is fairly close to the 26K of the SP1200. We're getting maximum audible frequencies of around 11.5 kilohertz, so that's giving us a noticeably darker tone than the original. The other thing we're getting is artifacts and aliasing from the pitching algorithm. This is the magic special sauce that the classic samplers imparted on sounds when pitching them, and is a huge part of the K.O.'s charm versus most of its peers, which tend to focus on more pristine, accurate audio. The K.O. is delightfully old school in that way. So this is already a pretty grimy sound, but let's see what happens when we take this to the extreme. I'm now going to load the 4 times sample in slot C1. Again, lower the pitch by an octave. Put it in one-shot mode. And we get this. Now this is a 4 times sample, so even though we've already pitched it down an octave, it's still playing back way too fast. Thankfully, the K.O. has another octave's worth of pitch adjustment at the group level. Just set your fader to control the pitch, and then turn it all the way down. That's 2 full octaves of pitch adjustment with 0 resampling or rendering tricks. I won't name any names, but there are a couple much more expensive samplers on the market that can't do that. So let's hear the result. That is an aggressively lo-fi sound. At this point, we're talking an effective sample rate of about 11.5 K, so we're only hearing frequencies up to about 6 kilohertz. But then all the pitching artifacts kind of fill in some of that void and sprinkle some high-end dust on there. This is super grimy, and that may not be your thing, but if you really dig the lo-fi sound and want that classic sampler experience, the K.O. is taking you places that its more clinical sounding competition just can't muster. So one last time, let's compare original sample, double speed sample, quadruple speed sample. There's a lot of range there, and you can experiment with different bit rates and speeds to find the perfect lo-fi sound. I hope you found this helpful, and I'll see you next time when I'll be exploring my workflow for sampling synthesizers with the K.O.